Okay, so today we're going to talk about 6.1. We're going to do vectors in the plane. Today we're going to do part 1. So chapter 6 is actually 6.1 and 6.2. We'll talk about vectors. 6.3 will be about parametrics. So we've done parametric equations before, so that's kind of, we'll go a little more in detail of that. And then 6.4, 5, and 6 are all about polar coordinates, and we have not done that before, so that's a brand new thing. But today we're going to talk about 6.1, vectors in the plane. Okay, on page 456, there is a blue box there that has a definition of two-dimensional vector. A two-dimensional vector in the book has a starting point and an ending point. The starting point is what we call the initial point or the head. Initial or the head. Whereas the end is the tail or the terminal point. Okay, the end point, the terminal point there, okay? So if this was, I don't know, let's say it's 4 and 3. This is 4 and 3. Okay. This is 4 and 3. This is what we call the vector V. And we denote that it is a vector by putting an arrow on the top. Okay, arrow on the top. All right. So that's how we denote a vector. In your book, it has also denotes it as putting it in a bold lettering there. Okay. So if it goes A and B, this is the terminal point, and this initial point here would be 0, 0, the origin here. Okay. Okay. So the way that we would go ahead and denote this vector V would be 4, 3. Now it's a vector, so we denote the vector as these type of brackets here. Okay, so that's how we do that. Initial point, terminal point. So if you go to page 457, there's a head minus tail. Head minus tail is that we start from the tail, and then we minus out the head to get the vector itself. So in example number 1, see if we can do that. Example number 1, we show that r is -4 to -4, 2. If r is -4 and 2, and 2s, and s was -1 and 6, -1 and 6, the vector here, from here to here, we'll call that vector A. We'll call that vector A. Vector A would be -1, the head, the tail, and then we subtract out the head here. So we're going to subtract out the 4, the -4. Okay? Well, that's the x component. And the y component, we go from 6, and we subtract out the 2. So negatives cancels out, we get -4, so we get 3, and we would get 4 right here. So that would be the vector from R to S. Okay? So and then the second part, we have a vector that is from P to Q, and we go P to -1 to Q. 5 and 3. So the vector, we call that B vector, is going to be equal to 5 minus 2, 3 minus 1, 3 and 4. Now as you can see, the vectors are the same. Okay, even though you have two different starting points, okay, the vector themselves are the same. They're called equivalent vectors, okay? So the vectors can be moved around in the plane and they will be the same vector. Okay, that's that. If you flip the page, it says, how do you define the magnitude? The magnitude of a vector is nothing more than the x component squared plus the y component squared and the square root of that. So we denote the magnitude by using these, and that's called the magnitude. The magnitude here is going to be 4 squared plus 3 squared is equal to, I have 16 plus 9, square root of 25 is equal to 5. Now, as you can see, we went from something that had a direction, because this has a direction, it has a direction going this way, to something that does not have a direction here. Something that does not have a direction we call a scalar. So this is a vector, this would be a scalar. So this would be a vector, or this guy here is a scalar. Okay, so that's the difference there. Scalar does not have a direction. This is magnitude only. In other words, velocity is a vector, because velocity has a direction, whereas speed does not have a direction. So the speed would be the scalar component of a vector. Okay, right? It is like mass versus weight. Okay, mass is just a mass. It has no direction, whereas weight actually has a direction because it's going down to the center of the earth. Okay. All right, so that's that. So that's how you find the magnitude. Let's see if we can do example number 2 here. In example number 2, we have find the magnitude of a vector represented from P to Q, where P and Q. So PQ, this is example number 2. PQ is from P and Q, so we would go P to Q. So this is vector from P to Q. So P was equal to negative 3 and 4. Negative 3 and 4. 2Q is negative 5 and 2. Negative 5 and 2. Notice that we use the regular brackets here because this is just a coordinate, a point. This is just a point, so we just use this, the regular notation that we're used to. Okay, from P to Q. So this is the head, this is the tail, this is the head. So the vector PQ is going to be what? Negative 5 minus the minus 3, 2 minus the 4. Now we use these brackets because it's a vector. Okay, so this goes like that, and I get negative 2 and negative 2. And the book actually, the question was, what is the magnitude of this? So the magnitude would look like that. And we go negative 2 squared is 4, negative 2 squared is 4, square root of 8, which is 2 root 2. Okay, so that's how you do that. So that was example number 2. Now let's go to vector operations. Now we can go and add, and we could subtract, we can multiply vectors. So let's see how we do that. So if I had a vector that is u, and we'll call this vector u1, u2, and I had a v vector, v1, v2. If I add the vectors, the way I add the vectors is I add the x's and the x's together, u1 plus v1, and then I would add the y's together like that. Okay, so that's how I would add the vectors. I can also multiply the vectors by a constant. So if I had kv vector, this would be the same as a constant k times v1, so v1, v2. So it would be the same as kv1, kv2. Okay, and we'll just go ahead and multiply the k into the x's and the y component. Okay, so that's how you do that. Okay, so let's see how that works out. So let's say that we're going to do So on page 459, it shows you what happens when you add the vectors. So let's say that we had a vector u, which was, we'll actually give them some numbers now. And we'll say this is 4 and 3. And then the v vector is 2 and 1. Okay, so let's see what happens. So let's say that, so let's draw the u vector starting from the origin, and we go 4 and 3, so it's going to look like this. This is the u, not the v vector. This would be the u vector. And we're going to add 2, let's add 1 and 2. Let's add 1 and 2. So I add 1 and 2 vector, it's going to look like that. So that is the v vector, and the resultant vector, if I add these two together, what do I get? I get u plus v, so I'm going to add 4 and 1, and I get 5, 3 and 2, I get 5. So the resultant vector is going to look like what? Right here, right? Because this is 4 and 1, so if I do that, the resultant vector looks like that. So in other words, go from here to here. So we go from head to tail, add head to tail. Head to tail, head to tail, so it adds up like that. So that is the resultant vector, okay? So in other words, you are just adding them up. You're going from head to tail, and that's how you would do that, okay? Let's say that I would subtract. So let's say that let's see what happens when I subtract these out instead, okay? So if I subtract them, what do I get? If I subtract u vector, and I go subtract from u vector the v vector, what do I get? I get 4, 3, and I'm actually going to add a negative 1, 1, and 2, right? So in other words, I'm adding the negative here, okay? So I'm going to get 4, I'm just subtracting that, so it's going to be what? 4, 3, plus, this is what? Negative 1, negative 2, if I do this in, right? Then I'm going to get what? 4, negative 1, I get 3, 3, negative 2, I get 1. So where is that? If I go ahead and graph that, where am I going to find that? I'm going to find that right here. I'm going to find, let's go ahead and use this one. I'm going to find that right here. So this is the resultant vector here, okay? So what actually happened is that I took this vector, this is where I started from the u vector. Instead of adding the vector, the v vector, I'm subtracting it. So I'm going to go ahead and flip this around 180 degrees. So instead of going up this way, it's going to go down this way. So I go from head to tail, and this is my resultant vector here. Okay? So, and this is not in your book, but I'm just kind of drawing you to give you a heads up, because this is going to happen, we're going to find this out later on. Okay? So we go v, and then instead of adding the v, I'm subtracting the v. So I'm adding a negative v. So negative v is the same magnitude, but it's 180 degrees the opposite direction. So that's how I'm going to do that. Okay? So that's that. And that kind of shows you in the page 459 how you add the vectors. Okay? So let's see if we do the example, the next example there. The next example is example number 3. Example number 3, where I have a u is negative 1 and 3, and I have v vector that is 4 and 7. I'm asked to find u plus v. So this is a u plus v. So I add the x's together, 3, add the y's together, 10. B is 3u, so I get 3 times u, which is negative 1 and 3. I do it in, I get negative 3. And I get 9. Then I have 2u plus minus 1v. So this is the same thing we did before, right? So I am subtracting v. This is actually 2u minus v, but we're going to go look and make it look like this, so it becomes an addition. Okay? 2u was negative 2 times negative 3. 3 times 2 is 6. Then I'm going to add the negative 1v was 4 and 7, right? So this is the same as negative 2, 6. I can do the minus in there, plus minus 4, minus 7. Add them together. I get negative 2 minus, so I get minus 6. I have 6 minus 7. Minus 1. Okay? So that's the operations. It's pretty easy stuff. Nothing too much going on here, really. Okay, then we're talking about unit vectors. Unit vectors. What is a unit vector? A unit vector is kind of like the unit circle. Remember we talked about the unit circle? And the unit circle is what? It is a circle with a radius of 1. That's a unit circle. So a unit vector is a vector that has a magnitude of 1. So if I had a vector that was 3 and 4, and I want to find the unit vector, I would take the vector itself and divide it by the magnitude of that vector. Okay? So I get the u vector itself, 3, 4, and then the magnitude of this vector is 3 squared plus 4 squared. So I get 3, 4 over, this is 25. Square root of 25 is 5. So how do I do this? This is the same as 1/5, 3 and 4. So I get 3 over 5, 4 over 5. And that is the unit vector. Okay? So let's verify that this is a unit vector. For this to be a unit vector, that means that the magnitude of this has to be 1. So let's see if the magnitude of this is indeed 1. The magnitude is squared plus this guy is squared, and it's the square root of that. So I get what? 9 over 25. 9 over 25 plus this is 16 over 25, which is 25 over 25 square root, which is 1. So indeed this is a unit vector. Okay? So that's how you find a unit vector. So the unit vector, basically what happens is this. I go from here and I am multiplying this by 1/5. It turns out 1/5 on this example. Okay? So it has the same direction. It has the same direction. So initially I started with a vector that was 3 and 4. So this is the vector that I started with. Okay. Now I'm going to go to here. So it's on the same direction. Okay. But it has, I am just multiplying by 1/5. So it's 1/5 of this magnitude. So I get like that. So that is the vector here. This is the vector over. This is the original one. The unit vector becomes down that's smaller like that. Okay. All right. So that's how that works. That's how the unit vectors work. So let's see if we can do some example number 4 there on the unit vector. Okay, example number 4. Example number 4, I get, find the unit vector of a direction vector v is equal to -3 and 2. So the v vector is -3 and 2. I want to find the unit vector of this, so I take the vector itself divided by its magnitude. So I get negative 3, 2. Square root of negative 3 squared is 9, plus 2 squared is 4. So I get 1 over root 13, negative 3, 2. So the unit vector is negative 3 over root 13, 2 over root 13. And that is my unit vector. And we're going to go ahead and stop right here today.